Operation. Welcome everyone. We'll move to the next topic in this, session: quality attributes of embedded system. If you look into the syllabus copy, the quality attributes comes with the second topic, right? It's just not a vast chapter, but you just have to understand few things in everything. Then you'll be able to write anything for final examinations. So what are the quality attributes? Nothing but they are non-functional requirements that need to be documented properly in any system design. What you have to do, the quality attributes are more concise and measurable, it will give the positive impact to the system development and to the end products. There are two types of quality attributes, that is operational and non-operational. In the operational, you have these six things. Although you can add, a few more things into it. We'll see that. So each of these things are, explained in the textbook, but you can actually, understand it. Just remember, in the textbook they have mentioned six. Although sometimes you might, you can see like these type of things like more than one. So here we have 3, 4, 5, 6, 7, 8 are there. We don't have maintainability. We have fault tolerance, performance, robustness. Okay, we'll see in the notes which we have prepared over here. See, they have seen quality attributes refer to the non-functional requirements that must be clearly documented and considered during a system design. So there are two types, and see, we will see just small, definition over here, which we have prepared. How quickly the system reacts to the inputs or event. The same thing we understood in the previous video, talking about the car accident. Most of the car, if you're driving and unexpectedly, like accidentally, you met with any crash or anything, any accident. What does a car do? It releases that airbag system, right? So what is the event? So here they are talking about inputs or event. What are the inputs or event? They are nothing but the crash, car crash, or any accident that has occurred. That is the event, which are read by the sensed by the sensors. How quickly the system reacts. What is the reaction? The airbag system is a reaction. Okay. Throughput, the amount of work done or data processed in a given time, like how many packets were sent within this amount of time and all. That's the throughput. Reliability, in the sense, how much you can rely on the system, like how long will it work without causing any error or something. How long will it perform? Maintainability, ease of performing maintenance tasks like updates and repairs. Maintainability, like you don't have, the system shouldn't be in such a way that you should keep on doing services, changing parts, any problems, like too much changes. For example, in a system like printer, you keep you have to keep changing the in refill ink refills and all. Although better technology are, they have developed like less ink consumption, and like ink itself will be of high quality, that will give you a long time, like less ink used for like a large amount of printing and all. It's just like that. Security, security is very important, because sometimes it can cause a harm to the user itself. Unauthorized access, or that is one type of security, like where the system itself is causing any harm, like washing machine is causing the wear and tear of clothes and stuff or something. In some other embedded system, the system is designed to perform a particular task, but there are some breach or any attacks in the system which will lead to the malfunctioning of the system. Safety, ability to operate without causing any harm or damage. Also, in in hospitals and other places where you use embedded system for monitoring patients at data and all those stuffs. Even there, the security should be high, because the system shouldn't perform any malfunction, and that will eventually lead to the death of the patient. So first thing in operational quality attributes, that is response. See, small definition. It measures how quickly the embedded system tracks and reacts to changes in the input variable or in the environment. Importance: fast response is often required, ideal in real time. You just have to remember the car crash thing. It's very easy for you. You can write that the same thing in the example part. Throughput: efficiency measures rate at which a system completes operations or processes data over a time. Measurement expressed in unit produced, see, unit produced per time or transaction per minute, hour, or day. Benchmarks: standard references used to compare and evaluate system performance. For example, card reader throughput could be the number of transaction processed per minute. Reliability. So in throughput also you can simply, like you can see, right, amount of work done in a given time, example number of packet processed per seconds. You can also use this example for your definition or explanation. Reliability, the probability that the system functions correctly without failure over a time. In the sense, for how long does the system work without causing an error? For example, if there are two embedded system, like say washing machine, but two different washing machines, like companies are different. One is the older generation, one is the latest, generation washing machine. So how they are reliable? The older generation probably might, go out of service after few years, but not few years, few months, a year or two. But like latest generation washing machines will go on for many years, like 4 to 5 years, and they have automatic features as well. So that is reliability. So metrics MTBF, mean time between failures, and MTTR, mean time to repair. So how often does it take the embedded system to undergo any repair, or if there are frequent failures, like what's the time between each failure? When did the first failure occur? When did the second failure occur? You can just mention about this metrics. Two metrics are there. One is mean time. Both are mean time. One is between failures and one is to repair. See, average time interval between failures, average time required to repair after a failure. Simple. So MTTR comes after MTBF itself. Critical systems should have MTTR in minutes to minimize downtime. Maintainability, ease with which a system can be maintained, repaired, or updated. Relation to reliability. So it has a relation to reliability. See, it's like interconnected. High reliability means less frequent maintenance. So if the system works for a long time without causing any error, then you don't have to worry about the maintenance of the system. For example, if you have an old washing machine and it's causing frequent problem in the motor or water inlet or outlet, so you just have to keep, you often have to keep cleaning the that drainage system, like somewhere the dirt or the impurities are collected and so like in a net, right? So you just have to like keep changing them. So that's a major problem. If the reliability is bad, you keep have to doing maintenance checkup and everything. In the sense, you'll have to keep changing the parts. So that is like a relationship to reliability. If higher reliability, then lesser maintenance is required. What is maintenance? It's nothing but the system shouldn't undergo any sort of like defer what do we say, a problem or something like that, like maintaining to be repaired or updated. It shouldn't be often, it shouldn't happen often number time, like more number of time within a less duration. It should be like rarely, it should occur rarely, like between few months, like 6 to 7 months, or once in a year or twice a year, like that. Types of maintenance is scheduled or preventive maintenance, periodic replacement or servicing. Example, displaying printer ink cartridge after a set of number of prints. That is maintenance. So there shouldn't be high maintenance for that. Like you have to keep changing cartridge in less amount of time. Like it's printing less number of sheets than it's less than the predicted print, like corrective maintenance, repairs due to unexpected failures. Example, fixing a paper jam in a printer, that is a maintenance. It has to be done manually, it can't be done by the thing itself. Then availability formula, AI is equals to MTBF into MTBF plus MTTR into A of I. It's nothing but you can check that in the textbook. See, so maintain that before failure we just saw, right? Oh, sorry, not here. See, mean time between failures divided by, this whole thing should come down. Mean time between failures plus mean time to repair. So that's the like formula where A of I is nothing but availability in the ideal condition. MTBF is that mean time between failures. MTTR mean time to repair. Coming to security. Here's security. Key measures: confidentiality, integrity, and availability. See, confidentiality, like protection against unauthorized access; integrity, protection against unauthorized data modification; availability, protection against unauthorized access to data applications for maintainability, availability. It's just common features for security measures. Example, CPDAs with user authentication to restrict profile access, that is availability. Admin versus user access level to protect data. See, admin has a lot of power, like things he can change or everything. He can entirely change the system, but user cannot do. So that's the context. See, suppose you develop an app or something embedded system, and the user is able to change the components or other stuff. So that's not a good thing, right? That's not a good thing. So availability, protection against, read only access to prevent unauthorized data changes. That is integrity. Availability is nothing but no one will be able to manipulate anything in the system, so that a web page is always available. That kind of example you can see, right? Safety definition: protection against harm or damage to people, environment, or property due to system failures or hazard. It's like basically a malfunction in the system. This is nothing but you're just keeping your personal details safe from others and not letting anyone to use everything. Just like what to say, authentication system and all. In safety, you're talking about actual real world. You know, okay, so you understood that difference.